Hi everyone, welcome. Today we are going to be looking at a general view of the subatomic particles, atoms, elements, molecules, and compounds, specifically to understand their relationship with each other. Starting off with the smallest of them all, the subatomic particles. We have the proton, which has a positive charge, the electron, which has a negative charge, and the neutron, which has no charge at all. It is neutral. These subatomic particles are what make up your atoms. In the center of every atom is the nucleus, and this takes up the largest portion of the mass of an atom, particularly because there are neutrons here, and they have the largest mass of all the subatomic particles. Neutrons are the heaviest. Protons are also found here in the nucleus. Electrons can be found on these oval-looking rings surrounding the nucleus. These oval-looking rings are called orbitals. Now, our atom is what makes up our elements, and our elements are all found on the periodic table. Elements cannot be broken down into any simpler substance, even by chemical reaction. That gives these their special place here on the periodic table. Each element is composed of one unique type of atom. So, for example, the element sodium is only made out of sodium atoms, iron is only made out of iron atoms, and bromine is only made out of bromine atoms. All the elements are made up of either one atom or two atoms. When referring to elements that are made out of two atoms, we call these diatomic. There are 7 diatomic elements, which include hydrogen, fluorine, bromine, iodine, nitrogen, oxygen, and chlorine. You'll notice the little 2 subscript after each elemental symbol. This means that there are 2 atoms that make up this element. Let's take a close look at a diatomic element and see what it would look like magnified. Take hydrogen, for example. If we were to look at a sample of hydrogen gas, we would see pairs of hydrogen atoms. In contrast, if we took a magnified look at an element that is not diatomic, like helium, for example, we notice all the helium atoms are by themselves. They are singular. Let's look at one more example. We have nitrogen on the left side and argon on the right. Nitrogen is our diatomic element, and argon is not. Nitrogen we see comes in paired atoms, and argon atoms are singular and independent from each other. Okay, so taking a step back, the diatomic elements can be further described as molecules, because molecules consist of 2 or more atoms. They can be the same type of atom or they can be different types of atoms. By definition, you can see why all of the diatomic elements can be called molecules, because they are all made of 2 atoms. However, all the other elements do not fit the description, and they are not called molecules in their natural form. Natural form is referring to the elements straight off of the periodic table. So I must stress that this is in their natural form because they are capable of creating a molecule. That is when they are combined with other elements. So when they combine together, like in the second set of examples, they fit the description of a molecule. So the first set of examples are molecules of the same type of atom, and the second set of examples are molecules with different types of atoms. If you need a visual of the second set, I'm going to give you one in a minute. So these second set of examples that are circled here can be further described as compounds. A compound consists of 2 or more different types of atoms. So we can clearly see that this second row of molecule examples can also fit the description of a compound. Therefore, these molecules can also be called compounds. Let's take a magnified look at these compounds. Take, for example, NaCl. We see one sodium atom attached to one chlorine atom, and this together equals a molecule. That is also called a compound. It is a molecule because it's made out of 2 or more atoms, and it's a compound because it's made of 2 different types of atoms, both sodium atoms and chlorine atoms. And this sums up the relationship between subatomic particles, atoms, elements, molecules, and compounds. I hope this was helpful for all of you. Until next time.